All right, thank you for joining us today. And in this video, we are going to talk about inverse function theorem, and we are going to focus on inverse derivative. How we are going to use the inverse function theorem to find inverse what derivative. And I hope you are enjoying the video. If you are enjoying the video, make sure you like, you subscribe, you share, you give out your comment. Make sure you are not learning alone, right? Help help a friend, share with friends to also learn, math, enjoy the beauty of math. Let's jump right in. So using the inverse function theorem, we want to find the inverse derivative, or we can also say find the derivative of the inverse of the function. So they are the same. Find the inverse derivative or find the derivative of the inverse of the function. They are the same. So I'm going to give you some steps that we are going to use throughout the process. Then you get used to it when you practice. So what's the first one? The first thing that I need to do is anytime I'm solving example, I need the formula, right? So this is the formula for calculating inverse derivative, right? Or this is the theorem, the inverse function theorem for calculating inverse derivative. So this is the first thing that you need to have in mind. So when you say inverse derivative, it means that we are finding the inverse of the function, and what do? We differentiate it. So that is the inverse derivative. I find the inverse of the function and differentiate. So this is what mostly I tell my student. If a question, if let's assume that the question is objectives and the question is using the inverse function theorem, then there is no need for me to use the inverse function theorem. Why? Because it's an objective and we are interested in you getting the right results, so that or finding the right results in the option. So this is what I do. If it is objectives, then I just find the inverse of the function, and then when I finish, I just differentiate. That's all. So if it is objectives, you just find the inverse of the function and you differentiate. I will show you how. But if it is, let me say, subjective, or let me say section B, where you need to write using it and we care about the steps, then you cannot use the shortcut that I was talking about. You need to make sure you write down the formula, you go through all the process together, right? Which I will show you. So first we need the formula, right? What do we need to do second? Now, looking at the formula, you can see that we need F inverse here, right? So we need to find the inverse of function, which we've learned from the previous video, right? We've learned how to find the inverse of the function. Good. Then, what is the third one? The third one is we need F prime. So we can see that here we have F prime. So we need F prime, which I have videos that is also coming up on derivative, right? So we do videos on derivative. So if we're not good with derivative, don't worry, I'll have full videos too on derivatives. So that is the third step. And then the fourth step is we can see that this is like a composite function. The F inverse is inside the derivative of x. So plug in F inverse into F prime, so which is going to be this. Then when you plug it in, what do? We simplify. So we will make sure we pick just the denominator here. We plug this one in, then we simplify. So when you simplify, what's the next step? We say plug in this into the denominator of the formula and simplify. So after I've taken this to solve, what I'm going to do is now I'll put my final results here at the denominator of the what? The formula. Then because it's 1 over, I just simplify. And when I simplify, my final simplification becomes the inverse derivative of the function, right? So now let's take simple example here, and then when you are done, you go to let us practice and solve more examples, right? So now let's go through this. What's the first thing that we need to do here? The first step was for us to find or write down the formula. So we need to write down the formula before we can start. So let me just copy my formula and just go and put it there. So copy, good, and let me paste it here. Oops, paste, good. So this is the formula that I need. So I write down my formula nicely. So let me write here solution, right? So the next thing that I need to do is let's go find the inverse of the function. So now let's pick this. We'll find the inverse, which we know how to do it already. So now let's find the inverse. That's the next thing. So for us to find the inverse, we let y to be equal to f of x, so which is going to give us y is equal to x plus 2 divided by x, right? Then we interchange x and y, so x is equal to y plus 2 divided by y. Then we make y the subject. So we know how to do inverse already, so I'll go quick. Good. So this will multiply this, then we make y the subject, so x y minus y and 2. So what I'm doing is I'm subtracting y here, subtract y here. So this one will cancel this. So here will be left with 2. And then I'll factor y out, x minus 1, which is equal to 2. Then y will be equal to 2 divided by x minus 1. So by making y the subject, I divide this one by x minus 1, x minus 1. This cancel this. And then I have this. So this is the inverse of the function. So the inverse of the function is 2 divided by x minus 1. So that is the inverse. So I'll clean the solution because we just need the inverse, right? But when you are solving it in the exams, you don't need to clean up the solution. You need it there. So since we are done with this one, I'll put this one here. Now, what's the next step? The next step is for us to find the derivative of the function. So now let's find the derivative of f of x. So f of x is equal to x plus 2 divided by x. I have full video coming on how to find derivatives, and it's very step by step. Like I've done it in a way that you, even if that's your first time learning derivative, you should be able to understand it. So this one, we are going to use one property of derivative called quotient rule. We say that this is u and this is v, right? So if I want to find f prime of x, then I maintain v, differentiate u, minus, now I maintain u and differentiate v, all divided by v squared. So I did this one and this one here because now u is the one up here and v is the one down here. And here you need to be careful because of the minus. If you bring this one here and this one here, your answer will be by negative difference of what I'm going to get. So make sure you pay attention to that. So what is u? U is equal to x plus 2. What is v? V is equal to x. So what is u prime? U prime will be 1. And what is v prime? V prime 2 is going to be 1. So now what is f prime? So f prime of x, using the quotient rule, which is here, we need v. V is x plus, nope, v is x, and then u prime is 1 minus, what is u? X plus 2, and v prime is 1, divided by v squared. So v squared. So let's simplify to get the derivative of f of x. So x minus x plus 2 divided by x squared. And when I simplify, we are going to have x and multiply the negative. I get negative x negative 2 divided by x squared, which is negative 2 divided by x squared. So this is the derivative. I hope you understood the process of finding this one. Okay, so now I need f prime of x. So I'll just pick the f prime of x here. Maybe I'll cut, or let me see, copy and paste it here. Good. Then I'll clean up the rest of the solution. Good. So now let's look at what we need to do again. So the next step is to plug in f inverse into what? F prime. Good. As we can see here. So it's a composite function. F inverse in F prime, right? Good. So now this is what we are going to do. We need F prime of F inverse of X, and this is equal to F prime. Now you ask yourself, what is F inverse of X? F inverse of X is here. So since this one is in, I'll put it here. I'll put this one here. So I'm going to have 2 divided by X minus 1, right? Good. Now, let's see something. For me to work with this, if those that they've watched my average and instantaneous rate of change video, whenever we are doing plugin, whenever we are picking a function, we make sure that our function given to us, so f prime here is equal to this. And we can see that this x here is in parentheses, so I'll make sure I put this x in parentheses so that it helps me to know what I'm doing. So I'll put my x in parentheses this way, which helps me to know that you see that I have x in parentheses here, I have x also in parentheses here. Now we can see that now if we need this guy here, now how can you solve? How can you find that? So let me swap this and bring this one down and move this one up so that we can continue the math. So this is equal to, now this is what I'm doing. Now you can see that this is in the parentheses is x. That's the reason why we have here. So now the one in the parentheses for f prime is now changing from x to the whole of this. So it means that the one in here to also change. The x here should also change to this. So this is going to give us negative 2 divided by x, 2 divided by x minus 1 squared. So what can you see? The one in the parentheses here is the same thing here. The one in the parentheses here is the same thing here, but same values as we can see. So the only thing that we are doing is we are changing the one in the what? The parentheses, because the one in the parentheses here is 2 over x minus 1, and then the one in the parentheses here is what? X. So this is what we are going to do. So the idea is that when we are done with this one, then we need to simplify. So let's do the simplification. So this is, if I have a divided by, if I have a divided by b all squared, this is the same as a squared divided by b squared. So I square the denominator, I square the numerator, right? So this is going to be 2 divided by, so this is what I want to do it so that we don't get confused. Negative 2, then this division, you see that this function here is divided by already. So I don't want us to get confused with divided by again, like having 1 divided by. So I'm going to write this one as divided by using this sign. So with this one, this is negative 2 divided by what is here. Then now I'll write this one here so that I can use the division. So this one will be 4 divided by x minus 1 squared, right? So I need to square 2, I need to square this one. Then I will have negative 2. Then I'll change the division sign to multiplication, which we are going to have it to be x minus 1 squared divided by 4 because we are changing it to multiplication. Then 2 will cancel itself 1 and cancel this one 2. So we are going to have negative x minus 1 squared divided by 2. So this is the simplification for f prime f inverse of x, which is right at the denominator, right? So after we are done simplifying this one, we put our final simplification into the denominator of the formula, right? So this is the formula, this is right here. So this is what we are going to do. This is going to be 1 divided by, what did we get for this? Okay, this is right here, and we had this guy here, right? Good. So we are going to have it to be negative x minus 1 squared divided by 2. So as I said, having division here is sometimes confusing. So I'll write this one as 1 divided by, so 1 divided by what is here. Then I'll write negative x minus 1 divided by 2. So I'll change the division to multiplication. So I have 2 divided by x minus 1. So when I multiply, I'm going to have negative 2 divided by x minus 1. So this is my final results by using the inverse function theory. This is what we are going to have at the end of the day, right? Now, let me show you the shortcut. The shortcut to this is, let's assume that this is not section B, that we need to go through the process, and it is section A. And I need to use the inverse function theory from the question. Then what will be the shortcut? The shortcut is very simple. What I just need to do is, since I just need the final answer, since I'm finding the inverse derivative, right, or the derivative of the inverse, then after I'm done finding the inverse of the function, I just differentiate. So now let's differentiate this function right here, right? Let's differentiate this function right here and see if we are going to have what is here. Okay, so let's try. Let's try. So this one too is a way of even verifying if your solution is right. So even if it is section B, you can go through all the process. When you are done and you have time, you can try to find the derivative of the inverse. So let's use the quotient rule that we just learned. U divided by V. So f prime, f inverse prime of x will be equal to u v u prime minus u v prime divided by v squared. Right, right. Good. So what do we need? We need u is 2. We have u to be 2, and we have v to be x minus 1, right? What is u prime? So a derivative of a constant is 0, and v prime will be 1. Good. So now let's do the substitution. What is v? V is x minus 1, x minus 1. Oops, I think the final answer here, we can see that there is square here. I forgot the square. So let's put the square on it. Sorry, let's put the square on it, and let's put the square on it. Sorry. Good, good. So I think that's how it's supposed to be. So this is going to, let's get back to where we were solving. So v is this, and then u prime is 0. So this one will be multiplied by 0 minus u is 2, and v prime is 1 divided by x minus 1 squared. So 0 times this one will be 0 minus 2 divided by x minus 1 squared. And this is going to give us negative 2 divided by x minus 1 whole squared. So can you see that this is the same as this? Good. So we do this when we are doing objectives and we just need the final answer. So I just find the inverse of the function, then I just differentiate the function, and I get my final results. Simple. But it's also helpful when I'm doing session B, and we need this idea of like confirming if what I did is right. You can, if you have time, you can just go through this. So in the next video, we are going to take more examples. We are going to practice and then look at different questions and how we are going to solve them. See you in the next video.